This is an experiment, a simulated experiment to determine the mechanical equivalent of heat. The apparatus here has a brass drum around which is wrapped a cord. When the drum is turned by the handle, the friction against the cord will raise this weight upwards, and this means we know precisely the amount of torque that's being applied to this drum, so we can work out the heat that is generated, the energy that's generated from the friction, because we know the torque. There's a counter on the apparatus that tells us how many turns we've turned it. So if you look at there and we turn it, you can see how that counts the number of turns. Now the apparatus starts with the temperature of the brass below room temperature, and the idea is to eliminate the inaccuracy that the heat loss to the room can incur by taking the apparatus up above room temperature by the same amount that it starts off being below room temperature. So as we turn the handle, we'll monitor that temperature till we get above room temperature by the same amount that it started below, and you can see the weight rising and the rope sort of buckling as the slack is introduced. And then we use the reading and the value of the torque and so on to calculate the mechanical energy that's been put in, and we use the specific heat of brass and the mass of the brass cylinder and its rising temperature to determine the amount of heat that's been gained, and that way we can determine the mechanical equivalent of heat. So a relatively simple experiment that works very well as a simulation, takes you through all the necessary calculations to get a result. Okay, thank you very much.